Hello everyone. Today we're going to be talking about setup time, hold time, and metastability with a quick example using Minecraft Redstone. So our component of choice here is the D flip-flop. And the D flip-flop has two inputs, clock and D, and one output, Q. Functionality of it is that on the rising edge of the clock signal, Q, the output, copies D's state. It's also possible to make flip-flops that are falling edge triggered, but here, as you can see, our flip-flop is rising edge triggered. Now over here we have three different signals represented by the gold blocks. We have clock, which oscillates between high and low predictably forever. We have D, our data input to the flip-flop, and Q here, our output of the flip-flop. So remember that the D flip-flop's functionality is that on the rising edge of the clock, output Q copies D's states. Now, that works just fine until we introduce the concepts of setup time and hold time, where setup time is the amount of time the input, in this case D, must remain stable before the rising clock edge for Q to behave predictably. And similarly, hold time is the amount of time that input D must remain stable after the rising clock edge for Q to behave predictably. So when these criteria are not met, then Q enters what's called a metastable state, which means that we won't be able to predict what Q is doing. It'll kind of behave pseudo-randomly. For our example, we'll be using a time unit of 1 block long, and we'll also be defining setup time and hold time to be 2 blocks long. All right, so if we go through time on these signals, we see that on the first rising clock edge, we go down to, excuse me, I'm going to get rid of this rain. We go down to on the rising edge of this clock, we go down to D to see what D is doing. We see that it has been stable for both the length of setup time and hold time. So then if D is high, then at this same point in time here, down at Q, we should see it copy Q's state, which it does, it goes high. And it stays high until the next check at the next rising clock edge. We go down here, we see that D is not stable between the rising clock edge and 2 blocks before it. It changes its state. So that means that Q will start to behave unpredictably and go into what's called metastable state, here represented by the red blocks. We have no way to really predict what Q does at this point. Move forward in time again to the next rising clock edge, where either it could be fixed, metastability could, we could figure out, the output Q might be predictable if D doesn't change. So we see that the setup time is not violated. We see that it's stable for these 2 blocks here. However, hold time is violated because it changes only 1 time unit after the rising clock edge. So that means that our Q output will still be in the metastable state here. We won't be able to tell what it's doing, or we won't be able to predict what it's doing. On to our final rising clock edge here, we see that again D is in a stable state for both the setup and hold time. So therefore Q will copy what D does and it goes low. All right, so I have a brief example over here, and unfortunately my smooth brain couldn't figure out a way to represent in Minecraft Redstone how to differentiate between hold time and setup time. So we're just going to say that because this input D signal is moving too fast for the clock, it goes into a metastable state, and we're not able to predict what the output Q does, represented by this piston here. So if we connect these up, we'll see that on the rising edge of the clock, we can't tell what's happening. At that time, it decided to go high. The next clock decided to go low. It didn't do anything. All right, cool. So that's the brief example in Minecraft Redstone. Again, this is just showing a metastable state. I can't come up with a way to represent it, represent the difference between setup time and hold time using this redstone, but hopefully this example over here gave a bit of understanding. So to finish this off, we're going to get rid of our friend over here, COVID-19, with a little TNT cannon. So I'm going to switch on this AND gate, and then on the next rising, or on the next high clock signal from this flip-flop, we'll get rid of our friend COVID-19 over there. Come on. There we go. Bye-bye. Oh, we're a little short. All right, well, that's okay. Thanks for watching.